Welcome to this beginner-friendly guide on C++ preprocessor directives. In this video, we'll unravel the mystery behind commands like include and define, and how they shape your code before it even gets compiled. Get ready to understand the power of the C++ preprocessor. So, what exactly are preprocessor directives? Think of them as instructions to the compiler that are carried out before the actual compilation process begins. These directives always start with a hash symbol. They're executed during a phase called preprocessing, and it's important to remember that they are not C++ statements, so you don't end them with semicolons. Here's an example of preprocessor directives in action. We have include iostream, define pi as 3.14159, and define square as a function like macro. These directives set things up before the main part of the program runs. Let's dive into the include directive. The purpose of include is to insert the contents of another file into the current file during the preprocessing stage. There are two main ways to use include. First, system headers. These are standard libraries that come with C++ like iostream, vector, and string. You include them using angle brackets. Second, user-defined headers. These are headers you create yourself for your own code, like myheader.h or util/helper.h. You include them using double quotes. The key difference is that angle brackets tell the compiler to look in the system's standard include directories, while double quotes tell it to look in the current project directory. Now let's explore the define directive. Define comes in two flavors. First, object-like macros. These create symbolic constants. They don't allocate storage, they simply perform text substitution. And they don't do any type checking. For example, you can define pi as 3.14159 or max buffer size as 1024. Second, function-like macros. These operate like functions but can be faster because there's no function call overhead. Make sure to use parentheses around your parameters to avoid unexpected behavior. For example, you can define square of x as x times x or max of a comma b as a greater than b question mark a colon b. While define can be handy, it's easy to stumble into pitfalls. Macros perform simple text substitution without any type checking. So be extra careful with parentheses and operator precedence. Look at this example. If you define square of x as x times x, and then you calculate square of 3 plus 2, you might expect 25, but instead you will get 11 because of the operator precedence. To fix this, you should define square of x as parenthesis x parenthesis times parenthesis x parenthesis. With the proper use of parentheses, the result will be what you expect. Conditional compilation lets you include or exclude sections of code based on certain conditions. The directives you'll use are if def, ifndef, else elif, and ndif. Conditional compilation is commonly used for platform-specific code. For example, you might include windows.h on Windows or Unix.h on Unix-like systems. It is also helpful for debug versus release builds and header guards and feature toggles. For example, in debug mode, you might define a log macro that prints messages to the console. But in release mode, that macro might do nothing. Header guards are a crucial technique to prevent a header file from being included multiple times in a single compilation unit. Without header guards, you might end up with redefinition errors. There are two common ways to implement header guards. The first one is ifndef/define method. You wrap the entire header file in an ifndef block, where you check if a macro like math_h is not defined. If it's not, you define it and include the header's contents. The second one is pragma once. This is a non-standard directive that tells the compiler to only include the file once. It's simpler, but not supported by all compilers. Let's quickly cover a few other useful preprocessor directives. Undef undefines a previously defined macro. This can be helpful to ensure that a macro is no longer in effect. Error forces the compilation to stop with a custom error message. This can be useful to prevent compilation if certain conditions aren't met. For example, if the C++ version is too old. Pragma is a compiler-specific instruction, which means that it is implementation-dependent. This can be used to disable warnings or enable optimizations. To wrap things up, let's go through some best practices. Always use header guards for all header files. Avoid complex function like macros that could be replaced by inline functions. Use parentheses in macro definitions to avoid operator precedence issues. Avoid using macros for constants when constexpr or const variables would work. In modern C++, there are often better alternatives to macros. Constexpr provides compile time constants with type safety instead of define. Inline functions offer type-safe replacements for function like macros. Templates are a type-safe and flexible alternative to macros for generic code. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.